I got to get my cheat sheet out. All my notes that'll be on there tomorrow. We're not reviewing today. Today's not a review day. I'm going to go over homework tomorrow, check it, and then we'll start the quiz. All right, not a review day today. We're going to move on in the unit. Okay, here's what you can expect. Some people actually care about this, so it's 32 points, if anybody's wondering, and that's going to help you sleep tonight. I do want you to remember, there are 3 methods of proving triangles similar. I know angle is the big one because that's what we've been using with proofs, but there are 3 methods of proving triangles similar. And don't forget about them because I'm going to test all 3 tomorrow. You do have angle. What's some more? Side, similarity. Now look, it's one thing to memorize that side's away. It's another thing, do we know what the S's mean here? That doesn't mean the 3 sides are equal to another 3 sides. What's it mean? The ratios are all the same. So you match up one pair, match up a second pair, match up a third pair, all 3 ratios should be the same. And then very similar, no pun intended, side angle side. The angle in between is congruent, but the sides around it are in the same ratio. I will give you a diagram tomorrow and say, are these 2 triangles similar or not? If so, what's the reason? And you'll have side lengths, and you'll have to match them up and see if it's side, or side angle side. Hi, Lauren.
Hi. Will we ever have to use like side, or side angle side on proof?
No. Not proving similar. No. It's always going to be angle. Yep. Don't even think about the other 2. But I am going to throw in some multiple choice tomorrow. Let's say, look at these 2 triangles. Are they similar? Yes or no? If so, what's the reason? Everyone good there? This isn't a shock, but I'll just write it down to be official. You will have factoring and quadratic formula tomorrow, where you set up your own proportion, cross multiply, and either factor or use quadratic formula. And there are 2 proofs on there, 2 proofs. And I have no problem telling you, both of them are going to end in CSSTP. Okay, both of them are going to end in CSSTP. We are going to go one step further today in class, but that's not part of it tomorrow. All right, both proofs tomorrow will end in CSSTP. The hardest part of those proofs, finding the angles. Okay, finding the angles. All right, where are the 2 pairs of angles that should be equal? That's going to be the toughest part tomorrow. And that's all I got for you. Any questions? It's a short test in the fact that there's only 7 questions, 8, but it's probably going to take you the full period because, as you guys know, these right here, factoring and quadratic formula, take a little bit. Okay, they take a little bit. Nothing at all? All right, what do you say we move on? Notes are short today. I only got 2 proofs for you. And then you have the rest of the time to work on the assignment, and tonight's assignment is also practice for the quiz as far as factoring and quadratic formula go. All right. Quick question for everybody. If I gave you this right here, 4 over x equals 6 over 12, how would you solve for x? How would you solve for x? Cross multiply, right? Everyone would do first, maybe 4 times 12. Today, those actually have names. Whatever's in the 4 and the 12 spot, in a proportion, those are referred to as the extremes. All right, the extremes. So over here, everyone see where it's A and D? Whatever numbers or variables are in those spots, those are referred to as the extremes of a proportion. The extremes. We're just going to put some formal vocabulary to it. And then what about the other 2 positions? In this case, x and 6 and b and c. Those are referred to as the means of a proportion. Extremes and means. A lot of people always ask, well, how can you remember what's what? Very, very corny, but how I remember it, if you look at this proportion going left to right, does everyone see going downhill left to right? Those are the extremes. I see downhill skiing, extreme downhill skiing. Oh, okay, great. You can bust my chops about it later, but all right, extreme downhill skiing. That's how I remember that these are always the extremes. However you want to remember it, though. So I multiply the extremes, 4 and 12, and I multiply the means, 6 and x. But what do I do with them? What do I do with them when I multiply them? Don't overthink it. I set them equal to each other. And there's your new theorem for today, is that the product, when you guys hear product, what are you thinking about? Multiply, right? The product of the extremes is equal to, anybody want to finish it? When I multiply the extremes, it's equal to product of my means. There you go. And again, you guys have been doing this for a while, probably since you're in middle school. We're just putting some formal vocabulary to it now. And now going to use it in a proof. And I know lazy might be the wrong word, but we have some students that like to take shortcuts as much as possible. Po equals pom, never acceptable. Get out of here. If anybody knows what I'm talking about here, as far as you want to try shorthand on me, po equals pom will never be acceptable. All right, we can write it out. All right, we can write it out. Anything you'd like to ask about means and extremes? And we're going to reintroduce these next unit too, means and extremes. So not the last time you'll see it. All right, so let's use it in a proof now, means and extremes. Don't mark your, please don't get marking your diagram yet. Can you just look at the proof statement? A little bit different of a proof statement, right? A little bit different. I'm asking you to prove 2 line segments multiplied together equal another 2 multiplied together. Can you talk me through this real quick? I can't multiply those unless I have a what? No, going too far ahead. I can't do ER times AD and TE times DD unless DT unless I have a what in front of me. Things don't get multiplied unless I have a what? Thank you, a proportion. And you know what? Darn it, I don't have a proportion, Paul, until I have a what? Similar triangles. Do you see the last 3 steps in our proof now? Triangles are similar. Write me a proportion so I can cross multiply it. So those are going to be the last 3 steps now. Similar triangles, proportion, let's cross multiply. Hey guys, how many triangles are in that diagram? I can't even count them.
1, 2, 3, 4,
Too many.
6.
How do we figure out which ones we need? What did we do yesterday? How do you figure out which triangles we're going to try to prove similar here? What did we use yesterday? Act like you've been there.
Look at what we need to prove.
Darn right. Jonathan, give me a segment in our proof statement. B, what is it? AD. Everyone look at, of course you picked that one. AD, look at AD. Everyone see why that doesn't help me? It could be a couple triangles that have AD as full sides, so thank you, Jonathan, for picking the only one that wouldn't work. Can you pick another one for me?
Yeah.
ER, all right, I like ER. Everyone look at side ER. Isn't ER a side in one and only one triangle? Which triangle? It's only a side in triangle ER. T. All right, so we found one. Give me another side that's in the proof statement other than AD, because as you can see, AD is not going to help me. DT. Hey, DT. That's a full side in what triangle only? DT. A. Got it. So those are the 2 we're going to try to prove similar by angle. We're going to do this one as a class. I'm going to call numbers out, and then I'll let you go in your groups and try out the second one. You guys should be thanking me here because of what I've given you. 1 pair of angles, pretty easy. All right, somebody get me a pair of angles congruent, please. Any pair congruent. 16. Any angles congruent up here you see? T, say those again. Yeah, you don't even have to tell me they're right angles. I gave them to you. That's why I said you're welcome. All you need to do is in step 2, hey, they're congruent. TER congruent to ADT. All right angles congruent. All right, there's angle. Where's the other A? Look at your givens. I told you this bad boy was isosceles, and I told you what the congruent sides are. So have another pair of angles. Oh, let me mark the right angles first. Right here and right here. Got the right angles. What's the other pair of angles equal up here? Oh, 4. Way to go, Griff. I didn't even have to yell at you. Good. Angle R and angle ATD. I don't want angle T. Not specific enough. Good work. Reason? You could say isosceles triangle implies base angles equal. I always use the theorem, the in a triangle one. In a triangle, congruent angles are across from congruent sides. Thank you, everybody. Thank you for your help in getting me the 2 angles. Now the triangles are similar. Just got to make sure I write it correctly. Triangle ADT. ADT and TER. Everyone putting the tilde, not the congruent sign. Be careful. Angle, angle. All right, so where do we go from here now? Again, you cannot go right to the proof statement. We already talked at the beginning. What do I need to cross multiply? I still need a what? Proportion, yes. And that's going to be really the new part for here today is how do you create, now the triangles are similar, your own proportion? So you match up the sides I need. And I'm going to make this very easy. Look at your proof statement. Give me 2 sides that you need to multiply. From the proof statement, just give me 2 sides you need to multiply. TE and DT. Where would they have to be in my proportion if I'm going to multiply them? I want to say across, yes, diagonal from each other. So hey, if I'm going to put TE right in the top left, I can only put DT bottom right. They have to be diagonal. And then you could put ER and AD in the other 2 spots. That's how you build your correct proportion. You got to make sure you're cross multiplying the correct values. Why is that true? Yeah, this is what we did yesterday. We're just extending it a step. CSSTP, because they're corresponding sides in similar triangles. And now here's our extra step. Let's multiply the means and extremes. So when I have a proportion, the means, the product of the means will be equal to the product of the extremes. Or vice versa. So product of the extremes equals product of the means. One extra step. And that's how far we'll go in these similar triangle proofs. Questions? Okay. You and your group, get after it. First, figure out the triangle. Make sure your entire group is in agreement on what 2 triangles you're proving similar first, because there's a lot up there. Make sure you're in agreement first, and then help each other find the 2 angles. And I'll write my response up here in a couple minutes.
This one is similar to triangle.
We don't need a side now.
Q. That's why I said I did not use. No,
Okay, here we go. I'm not going to write this all out, but I just want to make sure we're good at a certain point. I don't know if everybody did the opposite angles, but I think probably a majority of you did, if not all of you. All right, so angle R congruent to angle QPA in a parallelogram, opposite angles are congruent. Now here's where we may differ, and I need you to focus in to make sure you did it the right way based on how you did it. You could have said angle RQB, this one right here, was congruent to BAP, this one right here. If you said that, you would have needed to tell me that RQ and SP are parallel. Then those angles are equal because parallel lines imply alternate interior angles are equal. All good. Some of you may have chosen the other pair of alternate interior angles, which was C along with BQA. Those were alternate interior. If you chose to do those, you would need to tell me RS is parallel to QP along with RC, not RC. Yeah, RC parallel to QP because of extensions. So if you chose these two in blue here, you needed to add in the extensions part. And then you had angle, CSSTP, product of the means equals product of the extremes. And just to remind you about my piece of advice from last unit, if you're worried about getting the pair of parallel lines correct, put them both, right? Put them both. You're not going to go wrong. Put them both. Any questions I can answer here, where the two angles came from? And then everyone right now, look at your proportion. If I came over to your paper and cross multiplied, would I be multiplying QC with QP? And would I be multiplying AQ with CR if I came over and cross multiplied? No other questions, comments, concerns? All right, you can flip it over. I know the homework starts with proofs, but feel free to go to an algebra problem right now too and try that out.